products we're going to talk about today. I suppose just as a quick intro from EnergyWise, I suppose I want to say thanks first of all to Pat and the team at UCC for inviting us. It's a great honour to be invited in as a local Cork company. I'm incredible what you've done to date in UCC as well. I suppose for EnergyWise, we were founded in 2009. We opened our first showroom in Cork back in 2013. I suppose 2013 was the year the country was still struggling. So it was a bit of a risk, I suppose, opening a showroom for renewable energy products at that stage. We started back then with a staff of 3 employees. We're to date currently at about 75 employees, and I can see that growing significantly with the latest grant announcements there from last week, which is exciting times ahead for retrofitting homes. I suppose what separates EnergyWise from other companies is, I suppose, we take your project from concept to completion. We have many trades under one roof, so if you were doing a retrofit project, you could be looking at hiring electricians, plumbers, ventilation teams, and many more trades, whereas EnergyWise, we take the approach where we have it all under one roof. We'll design your product or project, we'll source all the products to install them, we'll commission the project afterwards. I suppose each individual project gets its own dedicated project manager, so you have one point of contact to deal with these multiple different trades. The services we currently offer, I suppose you get a brief overview there. You'll see we've many years experience of fitting heat pumps, underfloor heating, ventilation systems, solar PV and battery storage. And today we've invited Brian and Shane, who are 2 of our experts in different fields, to talk to you on these. I'll hand over to Brian firstly, and he's going to talk to you about heat pumps and ventilation.
Hello.
Hey, Brian.
Good afternoon. Thanks for the introduction, Darren. I don't seem to have control over the slides.
1 second, you should have it there now, Brian.
I don't even see where that is. I just see people's faces. How do you switch them over, Darren?
There you go.
Ah, that'll do. Okay. Essentially, first of all, just to clear up any clarification on what a heat pump system is. Basically, a heat pump is a device that moves heat from low concentration to high concentration. Everyone already has one of them in their house, whether they're aware of it or not, and that's called a fridge. Your fridge, you put warm food into it, it makes it cold, the back of the fridge gets warm. Heat pump tries to do the same thing. It tries to cool the outside world, and as a result of the heat it takes from the outside world, it puts that heat into your house. That's it in its simplest terms of what it does. There's a lovely little diagram there that shows the vapor compression cycle. You can read through. But to the left there, to the right is what you see is a typical heat pump installation. You'll have an outdoor unit, and that's the unit, in this case, an air source unit, and that'll gather the heat energy from the outdoor ambient air. If it was a geothermal system, it gathered the heat energy from either well water, ground borehole, etc. like that. Then inside the property, you're going to have some sort of interface device between the inside and outside. It might be an integrated unit like you see in the picture there. So that has a lot of the plumbing components of the system built into it and there's a hot water cylinder. Or you might have a separate standalone hot water cylinder. There's many different configurations even within an air source system. Each house, depending on the constraints and restrictions with it, will determine what system is the best solution to use for that particular house. Just moving on to the grant there, Darren, if you go to the next slide.
You should have control there, Brian. If you click forward, you should have control.
No. Which button? I don't see any interface on the screen.
Apologies, I'll have to share it again 1 second.
Yeah, no, there's something in front of it and I can't move it.
There now.
All right. So, as I understand, most people here are here for the reasons of looking about retrofitting heat pumps into a house. And this has obviously gained a lot of interest recently with the increase in the grant values and the grant schemes and measures available. Up until now, until the past few weeks, there was a €3,500 grant for an air source heat pump, for example. And we've been quite successful with that. We've done many jobs over it. We're doing them today, we're doing them tomorrow, we're doing the whole time. But there a couple of weeks ago, they announced a massive increase. So for example, in terms of just air source heat pump, they brought it up to €6,500 to retrofit an air source heat pump into your house. Now you see there's other values for ground source heat pumps, exhaust air heat pumps, etc. like that. In the vast majority of retrofit scenarios, it is going to be an air source heat pump. It's just the simplest type of system to install. If you were to go down geothermal, you'd be talking about digging up garden, drilling boreholes, etc. like that. And it makes it uneconomically viable in most scenarios for a domestic situation. There's two ways of going down the grant options, and that's in individual grant measures. So you get a grant for, say, heat pump, you get a grant for wall insulation or attic insulation, things like that. Or there's also a one-stop shop grant measure, and this again was just announced a few weeks ago, and this is where the contracting company will take care of everything from grant application, the installation, the BER, the house, the heat pumps, the heating control, the wiring, the plumbing. Everything would be under the one umbrella by the one company, so the householder just essentially has to engage that company to get all the works done. There's different, I would say, the house would only be applicable for either measure depending on its age. Say, for example, if you're just doing a heat pump system, a house built up as far as 2021 is eligible to retrofit a heat pump, provided it was occupied prior to the 1st of January 2021. Anything prior to that is eligible for a heat pump grant. If it goes down to one-stop shop route, though, it's only houses from 2011, prior to 2011, that would be eligible. So that was the case with the previous heat pump grant scheme, but by now bringing it up to 2021, it's enabled a lot more of the housing stock of the country to be eligible for heat pump systems. In terms of like what kind of houses are suitable or not suitable, in any case, the heat loss from the house must be good enough. You will not get a grant to put a heat pump into a house that's just going to keep losing the heat straight out through the walls, windows, roof, etc. like that. You'll only get a grant if the house meets a certain insulation standard, known as a HLI figure, or heat loss indicator. To determine if your house is eligible, this is essentially the grant process. If you just click to the next slide there, Darren, that I can't get the button. Here's essentially the heat pump grant process. So decide, is it something that you want to do? Engage your SEI assessor. So these are registered assessors, basically to do a BER in the house, but they look at it from the point of view, is the insulation measures good enough in the house to be suitable for a heat pump? If it's not suitable, there's no point in doing it, because there's no point in putting a new system into the house to produce heat at lower cost if that heat has been continuously lost. If the assessor said it's okay, you apply for the grant, you engage a contractor to do the works, the contractor comes out, or the contractor will give you a price for it. If you're happy with it, go ahead, do the works. And once the works are all done, the contractor will fill out their aspect of the paperwork for the claim to grant. The BER assessor has to do a new assessment in the house because the house has now changed. There's a new system in place, and fill out them, and you submit your paperwork off the SEI, and you get your money back into your bank account within a few weeks. So the process is relatively simple. For one-off grant measure, it's up to the homeowner to apply for the grant and to make sure that they have all their documentations and to employ the contractor to do the work of the BER assessor to carry out the assessments. One-stop shop option, though, the one contractor would be doing all these works, which takes a lot more out of the hands of the homeowner. One benefit that the one-stop shop is given, they're given a €2,000 uplift grant if your house will achieve a B2 rating from the heat pump measure alone. So that's not something that's available underneath the heat pump alone grant. So that's basically an €8,500 grant as opposed to €6,500. So these grants are all very generous. I got involved in heat pumps in 2006 when what was the Greener Home Scheme of grants there, and they were given very, very generous grants at the time there for new builds included, but they realised their mistakes from that in terms of not making sure properties were suitable before awarding grants and end up in a lot of trouble. So that's why it might seem like there's a lot of hoops to jump through under the current scheme, but there is reasons for that. It protects contractors, it protects homeowners to make sure that the homeowner gets a system that is suitable for the house, and some contractor doesn't just fly by night, say, this will do, put it in, disappear with the money, and left the homeowner with nothing working. There's one more slide there. It's about ventilation. Now, ventilation is not covered under the grant scheme, but in general, when there's energy upgrade works being done to a house, especially in terms of insulation, especially external insulation or join lines, etc., ventilation is a mandatory step for it. It is eligible to go with holes in the wall or window vents per se, but if you're doing a significant renovation or something in the house, a heat recovery ventilation system is another way of bringing the energy efficiency of the house up, reducing your bills. It basically brings fresh air in from the outside world, filters that air and supplies it into your living areas, bedrooms, etc. At the same time, it extracts stale air from bathrooms, wet rooms, kitchens, and extracts that air out of the house. Now, before that air goes out of the house, it meets a heat exchanger in the heat recovery unit itself. So a portion of the heat energy from that outgoing air gets transferred to the incoming air. A typical example is if it's 10 degrees outside and your house is at 20 degrees inside, your supply air coming into the house will be typically around 17 or 18 degrees. That means your heating system has 7 or 8 degrees of thermal uplift that it does not have to do for the air of the house, as opposed to having natural ventilation. If it's 10 degrees outside, it's 10 degree air coming in through the wall. That's essentially what I have in that. So I'll pass along to Shane there, just going through the PV side of things, and we'll deal with the questions then as they come. Thank you.
I don't know if you can hear me there now. Great. So if you can go back a step there. So look, I guess there's two big crises happening at the minute. Everyone is aware of the climate crisis is, I could talk about that as well, but Pat has already mentioned on that in the start, it's just as important as the energy crisis. But just to go on the energy crisis, I guess why we are here right now with electricity prices is essentially because our electricity generation is predominantly made up of gas. 55% of our electricity in Ireland is produced from gas. The rest is from wind power, coal, oil, hydro, etc. Gas is seen as a transitionary fuel to get us through to renewables, and I guess that's put us in a situation where gas prices and geopolitical problems with Russia and Ukraine have increased gas prices, which has transferred to electricity prices. The wholesale electricity price, and the unit time can be anything from €380 per megawatt hour, which is the equivalent of around 38 cents a kilowatt hour for the ESB to buy that. They're selling that to their customers for possibly 25 cents, 30 cents a unit, so they're making a loss. And this is going to be a problem for Ireland and Europe over the next few years, in that they will try to claw back. So electricity prices are probably going to stay high, potentially going to increase this year and next year as well. So if we can go to the next slide there. So just on solar PV, Ireland has the lowest penetration of solar PV in Europe, commercially and domestically. And the Irish government recognises that they need to increase that. There's currently a grant of €2,400 up to 4 kilowatts. There is no grant for battery storage as of last week. I think the priority is just to get solar on rooftops, get electricity, green electricity into the grid as much as possible, and reduce our reliance on fossil fuel. The benefit of solar PV is that you generate your own electricity. You pay less money to your suppliers with those high prices. With smart meters, you can also charge your battery storage at night time when electricity is cheaper. You can power your home in a power cut, essentially, if you have during storms. You can charge your electric car these days now from surplus solar as well, which is really good. And a new thing that's coming in is selling surplus energy back to the grid. Now, the feed-in tariff rate hasn't been set yet by the suppliers. It's been essentially left up to the Electric Irelands and the Bord Gáis, etc., to set their own rate. But if they don't set a decent rate or a fair rate this year, the CRU will step in next year and set a minimum rate. Your rating of your home. So if you can go to the next slide there. So I guess energy monitoring is really important to see where you're actually spending your money in the home. This is our breakdown from last year in our home. Our electricity cost for the year was around 1,800 euro, sorry, for the whole year. That's broken down by around 525 euro from the heat pump and 456 euro from one electric car. We've since switched to a second electric car, so that cost will go up this year. And you can see down there you can break down the fridge, the washing machine, the microwave even shows you how much energy how much cost that's using. One thing that we've done in our own home and that a lot of people could look to do is try to shift all their loads to the nighttime when electricity is cheaper and when CO2 production from the grid is lower, because there's more wind power on the grid, or more a percentage of wind power. So we charge our cars at nighttime. We run our washing machines, dishwashers as much as possible. Even our heat pump, we have a slightly higher temperature at nighttime, so that there's a more running at nighttime when the electricity is cheaper. And these are things that putting in visibility of where they're at. So that's pretty much it. And that's Darren. I don't know, do you want to take over there?
Yep. That's good there, Darren. Thanks, Shane. Thanks, lads. I know it was I kind of put you down to 20-25 minutes because and I know you could talk about heat pumps and heat recovery and solar PV for a lot longer, but I think it's a really good introduction to kind of the technologies. And the chat function is open if people want to pop in their questions. I know a few people have sent a few questions into me, and I'm going to start maybe, Brian, first with the heat pumps, if that's okay. And the first question is: somebody's living in a house from the 2000s. Is that, given the building standards at that time, is that house would you expect that to be kind of a heat pump ready house? It's a comfortable house. They got 1 or 2 cold rooms, but by and by it's comfortable.
It should be. And I say should because there was building regs, but in the early 2000s they weren't much adhered to. So I'd surveyed plenty of houses from the early 2000s, especially building boom houses, where they should have been more than eligible, but they were performing terribly. So it's not necessarily the age of the house, it's more the construction. Timber frame houses built on the cheap were the biggest culprits of being poor, but concrete built houses of the same time period are more likely to be eligible.
Okay, and I see there's a big change in the grant when they kind of brought it up to 2021, which covers that period of the decade.
It covers the building boom,
it covers the building
and the crash at the end of it as well.
Yeah, I suppose I had one person that was telling me if your house is cold, there's a bit of insulation and there's a bit of work required before you could maybe you add that into as well as a heat pump, because it'll just increase the load.
We always say just reduce the losses before you go look about generating the heat with any other source.
Yeah. I think these questions are coming in from somebody that has a heat pump on their mind. What's the annual maintenance cost of a heat pump?
Well, it's obviously going to vary from company to company, but say most manufacturers, they require that the systems be serviced on an annual basis for the warranty period. Now, so like say if we were servicing a system, we're not just servicing the heat pump, we're servicing the heating system in itself. So typically you're in around 200 quid a year, thereabouts.
Okay. So it's a bit more expensive than your typical oil foil boiler or gas boiler, but it's a bit more complicated too than a condensing boiler.
There's a lot more bits and pieces to go through. Like say, for example, we'd have about a 60-point checklist to go through in a heat pump alone.
Yeah, okay.
As opposed to just the fan and the burner nozzle.
Okay, perfect. They're coming in quick and fast, so I'm going to deal with them as they come in, and they're varying between solar and heat pumps. Typical cost of a 4 kilowatt panel install, excluding grant. Is there a ballpark that you'd be comfortable saying on a typical normal slope of roof?
I suppose if you're talking about battery storage, 5 kilowatt hour battery, 4 kilowatt peak system, you're talking around maybe 12,500, 13,000 euro before the grant.
Before the grant, okay. And without the battery, Shane, I suppose the battery's probably adding what, 3 or 4K onto it.
Battery's adding about 4K to the system. Yeah, the battery is probably the most expensive part of it.
Oh, yeah. Yeah. Okay, perfect. I hope that answers the question. You need electricity meter that tracks the time of use. Is that right for nighttime discounts? Yes, you should either have a 24-hour day and night meter. And I know some of the old houses, I know they're retrofitting the buildings with smart meters that will automatically do that for you. But yeah, if you go to your meter and you're able to see what the day and night is and the night load is, then that gives you that kind of day and night tariff. That's as far as I'm aware now.
On that, Pat, you do need a day and night meter or a smart meter for the time of use. But for exporting electricity, you don't actually need a smart meter, which a lot of people think they do.
Okay. So like, I suppose as a rule of thumb, if you're only on a 24-hour flat rate, then you're on just a 24-hour meter as opposed to a day and night meter. And a day and night meter is 1 meter. The newer ones are kind of 1 meter in the install, and you can scroll down through and pick out the day and the night use. With solar panels, is direction an issue for an installation? I suppose there's a lot of kind of talk out there that has to be south facing, but that's not necessarily so, Shane, is it?
It's not necessarily south facing will give you the most yield in the year. If you have an east-west roof, then you typically oversize the system to get more out of it. But south is always the premium. Okay,
perfect. Hope that has answered the question. A lot of people are looking for cost estimates off the back of post-it sleds. So they give typical cost estimates for an average house, detached, semi-detached, to install a heat pump. Like just a rule of thumb. I know you offer the one-stop shop, which I kind of want to get to in a minute, and I know you've got a great demo and product displays up in your site in Hollyhill. Any idea or any kind of cost range? In my head, it's around it's up to around the 13,000 to 14,000 euros before grant, isn't it? And it depends if you need to do radiators and things like that as well. Would that be fair enough, Brian?
That might be a bit on the high side, slightly.
Okay.
It depends on the size of the house. Like you say, if it's a big house, it's a bigger heat pump, so the bigger heat pump costs more money. If it's a small house, it's a smaller heat pump. Same amount of labor generally, but as you say, then if once the assessment is done, there's a HLI figure done for the house. Just say it's 2, a minimum figure. We have to do a room-by-room assessment of the heat emitters. So we have to go into, this is the bedroom, it's 4 meters by 3 meters, and there's a 1200 long radiator in there. We have to then go through the chart. Will that radiator give enough heat? If it doesn't, then that radiator will have to be changed. So some houses we've gone into, don't have to change any radiators. If there's all on the floor, it's not a problem at all. But we looked at some other houses and the rads would have been undersized for an oil boiler, never mind with a heat pump system. And then it can add a lot of extra cost if they have to put in extra radiators or increase them, or if they get special size radiators due to the constraints of, there's a window above it and there's a plug socket to one side and a door to the other. I mean, you have to go with a triple panel or a 4 panel rad or something, which then can drive up the cost as well. But typically what we're seeing like including the VAT is most jobs would be in, including the rads and stuff like that would be in the 12, 13 sort of grand sort of mark.
Okay, that's including
VAT, but that's before any grants, deductions or anything.
Okay, and that's for including the rents. And again, I suppose from what I see out there, a person living in a 2013 to 2017-18 home, typically it's a straight swap for the condensing boiler or the heat pump in terms of they're sufficiently insulated and the rad sizes are generous enough that. So
the better the insulation of the house, the smaller the radiators can be.
Yeah. So, and I suppose the assessment tells a lot, which kind of brings us on to the next question. Who do people go for the assessment? Is that something that when energy-wise, when you rock up to energy-wise, that they organise the assessment or they do the assessment for the grant process?
No, the assessment must be done by an independent assessor registered with SEAI. So they're all going to be BER assessors, but they'll have done an extra course just on that particular area. So you go into the SEI website, apply for the grant page, and you will see assessor. So select assessor, you click on that link and it'll give you a list of assessors. So you pick an assessor that's what's local to your area. They have to be independent of contractors per se, in terms of, like, say, I couldn't go out and do a BER assessment on a house and then try and sell them a heat pump. It might be fun.
And is the assessment a fixed fee, Brian? I see there's a 200 euro grant.
Different assessors will have different prices. Typically what I'm hearing is charges of between 400 and 600 euros. Now there is a 200 euro grant towards getting that assessment done initially, and then another €50 against getting the post-works assessment done. So it's 250 quid to cover the assessment.
Okay.
So they're typically between 400 and 600 quid on that.
Great stuff. Thanks, Frank. You're getting hammered with all the questions. I see. I know we're getting a small bit of noise interference. I just ask maybe people to just check their microphones if that's okay. And speaking of noise, it's kind of lovely segue into Caroline's question. She's heard heat pumps are loud.
No. Right. So the heat pumps must follow the same noise regs as oil boilers, at 45 decibels at 1 meter. However, it's the tone of the sound. Sometimes you might hear a boiler at someone's house and there'll be a horrible growling sound off it. That'll just penetrate through walls and hedges and everything into the neighbours. Whereas the most sound off the heat pump is when you're standing directly in front of it. It directs, say, an air source heat pump. It sucks the air in from the back and blows out the front. So it projects the sound out the front of it. So you could be standing beside it and it would be very quiet. You could comfortably have a quiet conversation or whisper conversation without any issue. Where people may have had issues if units were bolted directly onto the wall of a house or something like that, you could get vibration transfer. So you always try to manage it with vibration dampers or by not having it mounted to directly onto the wall of a house if it's a larger heat pump.
Okay, and the vibration damper is just those big black box of rubber, basically, that you see these things sitting on. Yeah. Okay, great stuff. I hope that answers the question. Fatma has 2 questions in one. She's got a gas system running at 65 degrees a few hours a day. Switching to a heat pump, no other insulation upgrades required, mean a warmer house. And then the next one is, the question, a follow-on question is, do heat pumps need to run all day? So I suppose typically, Brian, what would be the operating temperature range of a heat pump?
Most heat pumps of what people will be retrofitting into houses, they typically have an upper temperature of about 55 degrees. Now, there is ones that go higher. For example, I have one in my own house that goes to 80 degrees, but that's a different thing altogether. I live in a very old house. So you're typically designing the systems. If it's a radiator-based system, typically design it at a flow temperature of 50 degrees. If it's an underfloor system, you're typically designing it at a flow temperature of 35 degrees. Now, they don't have to run all day. The key is control, thermostat control. There must be thermostatic control to be eligible for the grant anyway. So if you have a thermostat in a room, if the room's warm, the thermostat's off, the heat pump's off. If the room's cold, the thermostat asks for heat and the heat pump comes on. The same way it should control an oil or gas boiler system. So it's not that it has to be on 24/7. It's available 24/7, but it won't necessarily be on. If you're in a house that has multiple underfloor zones, you could have different rooms calling at different times. So it could be feathering in and out. Something I should also point out, I forgot to mention, is pretty much all modern heat pumps are inverter driven, which means that their output is variable according to the demand. So if there's only a couple of rooms looking for heat, it'll be running at a low percentage, maybe 25% of its capacity. And as more rooms look for heat, it ramps itself up to match accordingly. And it'll also manage the flow temperature going into the rads or underfloor based on how cold it is outside. The colder it is outside, the higher the temperature to the rads or underfloor. And conversely, as it gets warmer outside, the temperature goes down.
Okay, that's
so
really interesting.
So as hard as it has to.
Okay, so it's really interesting. So the heat pump is on, but it's only on then when the temperature drops to outside your limits. It comes on, tops up the temperature, and then stands back again for the day. So in theory, your house should never be kind of cold, and you're heating it from cold in the morning. You're maintaining a comfortable indoor environment in an energy efficient way.
Yeah, just some studies that we've done with, say, underfloor heating. We found that scheduling underfloor heating with a heat pump, say having it come on for X amount of hours in the morning and X amount of hours in the evening, versus just having it available 24/7, so each thermostat can call for heat as it needs to be. We found that it was about 15 to 17% lower running costs by having it available the whole time. Now, if you're in a house with just radiators, that doesn't stand to the same regard. You're better off just working on demand. So set your thermostats at the times and temperature you want and let them manage it. Now, the heat up time, if you're supplying 50 degrees into a radiator instead of supplying 70 degrees into the radiator, the heat up time for that room is going to be longer. So it's just a little bit of a matter of, I say, learning. You say, okay, I want the place warm at 6 o'clock. Instead of turning on the heat at 5:30, I might be turning it on at 5 instead. The same amount of thermal energy will be put into the house, but the amount of primary energy you consume, as in the electricity to run it, so would be less. So typically with a heat pump, for every 3 units of heat that goes into the house, you're consuming about 1 unit of electricity. With underfloor system that goes a bit higher, you typically get about 4 units of heat for every 1 unit of electricity you put in.
Okay. Okay. Excellent. Excellent. Dean Venables has a question. Thanks, Dean. Dean walks into Energy Wise tomorrow. What is the current kind of project start to completing kind of scheme that you would see in terms of getting your house retrofitted?
You want that, Darren?
Yeah, I suppose the current scenario with the one-stop shops is there's actually no one on the one-stop shop list at the moment. So the SEI have launched one-stop shop. There's actually no contractors on the list at the moment. All the applications are going through currently. So lead times, I suppose, if you were to come to us looking for a retrofit of a heat pump, putting in solar panels, you're probably talking six weeks typically from start to finish by the time all assessments are done and get the work carried out. But I suppose the current hiccup is the one-stop shop scenario. If you're going down that route, we're still waiting on SEI to confirm the list.
Okay. And do you expect to be a one-stop shop? Dan, you're applying for that, is it?
We are, yeah. Our application's going through as well at the moment.
Oh yeah. Okay. Okay. So that's a reasonable time frame, isn't it? 6 to 8 weeks in terms of it's kind of lining yourself up for the summer when the weather's there to do these kind of projects, I'd say. Okay. Thanks. Would a specific BR need to be achieved with the one-stop shop? I think Brian might have answered that in terms of I think there's a bonus for getting to a B. Is it, Brian?
You have to get to a B2 with the one-stop shop.
Yeah.
The individual heat pump grants, it's not about getting to a specific rating. It's just more about offsetting a fossil fuel system.
Okay. Okay. And is it difficult to achieve in an old house, for instance, a traditional cottage? Well, Carol Ann, you have the expert on here, Shane O'Sullivan. Again, nationwide, the RTE site crashed on Monday night with his cottage refurbishment. So I suggest you kind of have a quick look and maybe a call to Energy Wise afterwards, because I know, Shane, it looked amazing. Fair play to yourself and your family, the work that you've done in your cottage. Michelle comes in about the app, and again, that caught my attention too on Nationwide. What's that? Are you selling that? Is that a product that you have, or was it something, Shane, that you kind of Googled? Let's say.
No, it's a Wibby. I suppose you could install it yourself, but Energy Wise are installing them and setting them up completely. You know, normal energy monitors like Smappy's or other things will just measure 1 or 2 loads, whereas this learns wash machines, fridges, everything in the house.
Okay, so when you turn on the washing machine, it picks up a certain voltage or a certain frequency of that, and you assign that as the washing machine, and then it learns that as the washing machine.
It knows the washing machine cycle. It knows the fridge compressor up and down. It learns those over time.
Okay, fantastic. Good stuff. For a house built in 1980s that need Windows updates, would this be included in the grant? Is there a grant, lads, for replacing Windows?
Under the one-stop shop, there is for window upgrades and door upgrades up to 2 doors. I think it's 800 quid a door. I can't remember what it is for Windows offhand. We are seeing that in, say, some older housing stock. They say the assessor will assess the property. It mightn't reach the level required for a heat pump, and they'd give an advisory report on what measures need to be completed to get the house up to level. Sometimes it might be just an extra roll of insulation in the attic, but sometimes it could be, they could be just old windows and said, no, the windows need to be changed, and then that obviously is a whole different project scale in terms of cost.
Okay, good stuff. Thanks for the comment, Rosarie. Catherine, how much does a stop shop cost? PV pump all in for 4K. Is the battery necessary? So I think the lads kind of, you're looking at 12K kind of high level cost for both options. So you wrap that up into 24. But again, it sounds like these are all kind of indicative, and it's really worth kind of maybe getting the house assessed or calling a follow-up call with Energy Wise to go through the plans and the projects. Is the battery gone? Yes, I think Shane covered that in the talk in terms of they're just trying to get PVs on the roof. I'd imagine batteries will come in again. I think it closed in February. Can you connect the heat pump with existing rads? You sure can if the heat pumps, if the rads are large enough. Typically, engineers would oversize things, so typically the rads would be bigger than what you actually need. But again, the assessment is probably warranted there. But yeah, I think in a lot of cases, people can use the existing rads. Any recommendations for smart plugs to measure energy consumption in the house? I know Shane's product there, Barry, was something that is the lads sell above and can fit. We have a very simple 24-hour plug monitor that you just plug in, and it just takes the instantaneous load. They cost about €50, but they don't give you any data or any backup, but it just gives you that real visual when you're running something. You can see how much is taken.
Yeah, and just on the Wibby path, you know what's important if you have smart meters with day rate, night rate, and the 2 to 4 a.m. rates, you can put that into the Wibby, and it'll automatically calculate the cost over the year.
Okay, fantastic. And like everybody loves a good graph and a good breakdown is lovely, isn't it? In terms of like that's data and that's evidence that the heat pump is, you know, that's how much it costs you for the year, you know, which is great. Great question from Sally. What is more efficient value for money, solar PV or thermal solar for the water?
Solar thermal would have been cheaper back in the Celtic Tiger years, so solar PV was more expensive. The tables have turned and solar PV is cheaper now. Solar PV is way more flexible. With solar thermal, there's only so much you can do with hot water. There's only so much hot water you can charge your battery. Way more flexible.
Yeah, I think that I get the impression of that too. Like it's kind of solar thermal seems to be kind of on the way out. The lifespan of the panels and the heat pump in general, 10, 15 years.
Well, I know of heat pumps from 2006 I would have been involved in and they're still purring away, so I don't know yet.
Okay, that's a good answer. I'm still here, says you.
Yeah,
okay.
Solar PV is no moving parts in solar PV, so the panels pretty much last at least 25 years. Solar thermal is a different story. There's maintenance in it, glycol. So solar thermal is a different story.
Yep.
PV is
a good point actually, Shane. So Rosario is saying, can I summarize? You were suggesting that heat pump is the way to go. I think the government policies and the grant applications and everything else is, you know, when we spoke earlier about moving our thermal emissions, reducing them, we've still very high carbon emissions associated with thermal. So I think that's what the government are backing on is at the moment is heat pump technology. Welcome. Okay. Somebody's going to watch it this evening, Shane, which is great. You'll have more hits again. Could these doors, I've been told that PVC doors are less secure from a burglary point of view. I'm not too sure what the question is there, Christine, but hopefully I'll come back. For external installation, I've heard that it's difficult to get people to install brand burn TV afterwards as they don't want the damage. Have you come across that?
Sorry, say that again?
When people installing external installation, I suppose the last thing they want to do then is drill on it. In terms of, you know, penetrate it for like service ducts, whether that's ventilation, whether that's satellite cables or broadband cables. You go to all this trouble of wrapping the house and then you drill through it.
Yeah, I'm not sure if there's.
Yeah. I know there was a house down the road from us was insulated and again it was they did put in I was watching it sadly, they did put in a 20 mil pipe that they ran all the services through and then they sealed that pipe up then, so it wasn't a case of a few drills across. It was, here's a duct for you if you want to run services and just make sure you stop it afterwards to seal up the house. And I believe I skipped the question. What is the average cost one needs to spend to fit a heat pump? I don't think I did. I think we were looking at about the 12 grand mark, and that was including rads and things like that. And it all depends on the assessment, whether the rads are compatible and whether also what kind of upgrades you might need to do to make your house to be suitable. So I think that brings us up to 2 o'clock. And we've had 2 sessions. Dan, Brian, Shane, you've been the most popular one so far. That's fantastic. We hit over the 60 mark there for some of it, and we kept most of the people for the talk. So really on behalf of UCC and the Green Campus, and it's great to have a local company present to us, and hopefully we'll see you over, I would imagine there's going to be a follow-up to these conversations, and maybe when the one-stop shop comes up, you'd be able to kind of come back to us again with what the service offering is, if that's okay.
Good stuff. Thanks a million, Pat.
Cheers. Thanks everybody for joining, and take care.
Cheers. Bye-bye.